Now, okay. We'll have to pause partway through and stop the tape and start it over again because it won't do a full hour and a half. Okay, so here we go, number one. We are going to solve this equation. And the first thing we're going to want to do is what? Well, we're going to want to factor anything in the denominators that factor. So we're going to want to factor that last denominator. Then we can see what our common denominator is, right? What's our common denominator? X and x plus 1. So I am going to literally multiply. Ms. Ford's not going to shortcut. She's not going to trust to do it in her head. She's going to actually multiply everything times x and x plus 1. Because my grade's important to me, so I'm not going to try to shortcut. I'm going to just write it all out. Now, what happens? Well, here, these x's cancel, and I end up with x squared minus 3x plus x minus 3. That's what I have left in the first term, right? Now, here, these are going to cancel, and all I have left is minus 3x. Here, everything cancels. All I have left is a 3. And what happens on that side? What happens over there? 0. All right, so here we go. Let's collect like terms. We've got x squared, okay, minus 5x. How do I solve that? Factor out an x. So it looks like my roots are x equals 0 and x equals 5, but what do I always have to be careful about? Extraneous roots. Are either one of those extraneous? Yes, because if you put a 0 into this problem, what's going to happen?
It'll be 0.
You're going to have a 0 in the denominator, which is not allowed, right? So the only answer to the problem is 5. Now, number 2 is a two-parter, done the same way, but just in 2 parts. The first one says, here's my function, f of x equals all that, and I'm going to plug in x minus 2. That means I'm going to take out the x, and every time I have an x, I'm going to plug in x minus 2. So I'll have 2 x minus 2 squareds minus x minus 2 plus 1. See what I did? Kids, that's no different than if I said, here's a function, find f of 3. What would you do? You take out the x's and put in 3. This time we're putting in x minus 2. And now we're going to simplify it. This is a FOIL. This is a FOIL. I'll say it one more time. This is a FOIL. So we have x minus 2 times x minus 2. So we have 2 times x squared minus 4x plus 4. Minus x plus 2 plus 1. Don't forget to distribute that negative right there. So we have 2x squared minus 8x plus 8 minus x plus 3. Did you end up with 2x squared minus 9x plus 11? Is that what you ended up with? Double check my arithmetic.
Yeah.
Now, one of the biggest mistakes that can be made here is somebody will try to do the quadratic formula or something on that. Is that an equation set equal to 0? No. Does anywhere in the problem it say solve? No. It just says evaluate. This is what you get when you take out the x's and plug in x minus 2. Okay? Now, there's a second part to that problem. It says find f of negative 3i. Okay? So that means we're going to do exactly the same thing with the same problem, but this time we're going to take out the x's and put in negative 3i's. So what's negative 3i squared? Well, it'd be 9i squared. What's 9i squared? Negative 9, remember I squared is negative 1. So plus 3i plus 1, so what do we end up with here? Negative 18 plus 3i plus 1, negative 17 plus 3i. Oh, number 3 is kind of recent. How do we change degrees into radians? Pi over 180, I heard somebody say it. Pi over 180 equals x over 100. So x equals 100 pi over 180, which we can reduce to 5 pi over 9. Easy, easy, easy. Number 4. Remember, I'm jogging your memories, hopefully. Hopefully something we've done so far looks familiar. Now, this is a compound inequality. To solve it, I've got different options. I think I'm going to leave it in one piece and just get the x by itself. So just like a regular equation, the first thing you're going to do is add 8, but we're going to add 8 to everything. So we end up with 6 less than 4x less than 14. Perfectly legitimate to do that. Now what will I do? I'm almost done. Divide everything by 4 all the way across. So 3/2 is less than or equal to x is less than 7/2. Now, I do want to remind you that this test is multiple choice. So it is entirely possible, especially since the honors teachers are involved in writing it, that this will not, the answer, like, A, B, C, whatever, it won't look like this. It will look like this. You've got to remember your interval notation. Remember the bracket is the or equal to, means the closed dot, and the parentheses is the open dot or the not or equal to. These two things mean exactly the same thing. You have to be aware of both because you don't know what form the multiple choice answers are going to be in. Oh, number 5 is an easy one for you. You should be able to do this one very quickly. We want to change that to degrees, so we remember that pi is divided by 6 times negative 5, negative 150. Boy, that was easy. We hope there's a lot like that one. What is the domain? Remember that when somebody talks to you about domain, there's 2 things you have to worry about. What are the 2 things? You can't have a negative under a radical. Well, I don't have to worry about that in this problem. And what else? Can't have a 0 in the denominator. So here I do have to worry about that. So what is my domain? Everything except what? Negative 3/2. This cannot be 0. So solve that. X can't be negative 3/2. But again, I don't know. Actually, I do, but I can't say. I can't tell you how the answer to this is written. It might be written like this. It might also be written like this. That means everything except negative 3/2, because this describes everything on the number line up to negative 3/2, but not including it. And this describes everything beyond negative 3/2. So this describes the entire number line except negative 3/2. Remember, this means it's not included. Okay, number 7. Easy peasy. What are we doing in problem 7? Well, if it factors, it's a quadratic. So you're going to solve it. And if it factors, you'll factor it. I do not believe that factors. So what am I going to do since it doesn't factor? quadratic formula, which is
Opposite of b x equals square root of b minus 4 times
B
Square minus 4ac.
Sorry, I'm sorry.
Hey.
I apologize.
well, we certainly don't want to miss that on our exam. Okay? So here we go. Negative b would be 4 plus or minus 16 minus 4 times 2 times 1 all over 4. Does that look okay to everybody?
Calculator problem 7.
Actually, unless there's a star next to it, it's a no calculator problem, so we should be able to do this without a calculator. Annabelle, I believe that you probably can take 16 minus 8 without a calculator.
No, I was saying the next one.
No, she
I
won't.
know how to do
Oh,
that.
she's
lost
No, I promise.
Good girl.
I was looking at it. Don't
Now, I do want to mention something here. That reduces, right?
Of course it does.
Remember the triangle. If you can cancel something out of all 3 positions, not 2 of them, all 3 of them, then you should do it. So your answer would be 2 plus or minus root 2 over 2. Okay, all right, Annabelle's got the calculator out for the next one.
So excited.
This is definitely a calculator problem. Keep in mind that where exponentials are concerned, whenever you have a variable in the exponent, you have 2 options. One is to make these numbers match, get a common base. Obviously, it's not possible to make 11 and 8 match. If this had been a 4, I'd be in business, but it's an 11. So I'm going to need to take the logarithm of both sides. And you will recall, hopefully, that you do that so that the exponent can come out in front. We can't solve the problem if the exponent's up there. We gotta get it down. So 2x plus 1, log 11, equals log 8.
And you solve.
Now you can solve this any way you want. You might consider dividing by log 11. So you have log 8 over log 11. Now you're trying to get x by itself, so next you'll probably subtract 1. So now you've got log 8 over log 11 minus 1. And then you'll get that number and divide it by 2. So if we all do that, because I'm sure we all brought our calculators, tell me what you got. Negative x equals negative 0.0664.
Yeah.
Now, I do not want to use up my video time going through that. Put a star next to it. When we take a little break, I can help you with your calculator if you can't figure it out. That's the right answer. Okay, number 9. Annabelle, it has a star next to it.
Calculator.
Groupies, this is the same problem, except instead of LOGing both sides, I'm going to LN. And the reason I'm going to natural log both sides is because there's an E, and it's going to be more convenient. So I will LN both sides. And what happens when you natural log an E? Whoops, they're gone. So 7x minus 2 equals ln 10. I will add 2 and divide. So ln 10 plus 2 over 7 should be my answer. And that is what?
0.614. How did you get that? I got
0.61.
Yep, you are right. Actually, 0.615, depending on how I round, right?
No.
Perfect.
What do you want?
ln.
Again, if you've got an issue with that, you're just gonna have to wait till break and we'll solve that.
Enter after everything. Oh, you don't have to fill the sheet.
Okay, now we have a multi-part question.
Oh, no, that's the big one.
We need to list the possible rational roots and then we need to find the roots. So the possible rational roots, my class refers to those as PRRs. Some of the rest of you guys might call it P over Q or something like that. We're looking for all of the possible rational roots. Those are factors of 27 over factors of 3. So all the factors of 27 over all the factors of 3. I do want to caution you that includes not just 27, 9, 3, and 1, but also 1/3. You see how 1/3 comes into play there? Because you have to take 1 over both of these. So 1 over 3 would give you 1/3. Now it says, listen, it says now find the roots. Okay, there is no star next to this problem. If the thing factors, you should always factor it because that's going to be fastest. Okay? So take a look at the problem. It looks promising, doesn't it? So I believe that I am going to group the first two terms and take out a 3x squared, leaving me with x plus 1. Now I'm going to take the last two terms and take out a 27, which lo and behold leaves me with what? The same parentheses. This is very good news. So now I'm going to write down the factor that repeats. So I'll write down the x plus 1. And then I'll smush everything else together. So I have 3x squared plus 27. Notice when I write this down, I don't square it or anything. I just write it down. And then everything else goes in another parenthesis. So it looks like x equals -1, or 3x squared plus 27 equals 0, which means 3x squared equals -27, x squared equals -9, which means x equals plus or minus 3i. Notice that the problem says find all rational and complex zeros. If by chance the exam contains a problem that does not factor by grouping, then you will go to your list and you will start plugging them in or dividing them, right? Trying to guess a number. That's when we guess. And we try to get 0 as our remainder. Hopefully that won't happen. Okay, number 11. Okay, we're going to solve this guy. What is your first step going to be? Add 7. That must be your first step. That has to be your first step, gang. You've got to get the absolute value by itself. Hey, dude. Now, what we have to do next, we have a choice. If you want, you can split it up into two separate inequalities. Right? Once you get the absolute value by itself, you can say 4x minus 3 equals 8 or 4x minus 3 equals -8. Do you remember doing that in your life? Well, you did in first year algebra and second year algebra. So now you can solve both equations. So 4x equals 11 and x equals 11/4. Or 4x equals -5 and x equals -5/4. Now another, just quick comment, just smart test taking. If this is a multiple choice question and you truly can't remember how to solve it, and I hope you can, but if you couldn't, you could just take the multiple choice answers and plug them back into the problem and see if they work, right? So that's always going to be an option. I wouldn't count on doing that for every problem because you won't get the test done. But if you're in a pinch, that will always work if it's a multiple choice question, which that one will be, I'm sure of it. Okay, next. Find the vertex. The vertex is a point. How am I going to find that point? I've got two options. I got an easy option and a harder option. Let's go with the easy option. What's the easy option? Negative b over 2a. That's exactly right, Maria. X equals negative b over 2a. So the x coordinate of my vertex is negative 1. Negative b over 2a. Now how do I find the y coordinate? I plug it back in. And when I plug in negative 1, watch it, when you square negative 1, it turns out positive. Minus 6 minus 1, negative 4. So your vertex is at negative 1, negative 4. How does this curve compare to x squared? Okay, now remember your BFFs? Folks say no. Yes, you got to know your BFFs. So this is a parabola, right? Vertex at the origin and opening up. Well, what can you tell me about this parabola? You just figured out that its vertex was here. So what have you done to this parabola? You have moved it 1 unit left and 4 units down, right? Because now it's sitting down here. Now what else have you done to it? Pay attention to this number. What else have you done to it? You've made it skinnier. So if this is like the normal one, the one we are graphing that's left 1 and down 4 would be a skinnier version of that. Right?
Yes.
All right, number 13. This is a no calculator problem, so if you think you're going to sketch it on your calculator, you're wrong. It doesn't say sketch. Oh, actually it does, D. So I'm going to go ahead and just sketch it as we go, and then we can answer the questions. When we did these, we started out by putting dots on the x-axis, and we just called them dots. That's not very professional. They're the x-intercepts. Where would those dots be on the x-axis? At 1, 2, 3, at 5, and at negative 4, right? Those are your x-intercepts. So the first question says, what are the x-intercepts? There they are. They come straight from the factors. The x-intercepts come straight from the factors. Now what is the y-intercept? Well, kids, there are several questions on the exam about y-intercepts, and it doesn't matter how ugly the equation is. To find a y-intercept, what do? Let x equals 0. I don't care what format the equation is, what it looks like, how big, or it doesn't matter. If you want a y-intercept, you let x be 0. So if I put in 0, I get negative 1. Watch this one, you actually get 16, and negative 5. So where's my y-intercept? 80. My y-intercept is up at 80. Now let's go ahead and sketch this thing in. What's the degree of that equation? That's a 4th degree equation, and we remember that 4th degree equations start up, end up, right? So this guy starts up here. Now what does he do when he hits this point? He bounces off because that point came from a squared factor. So he bounces off. He's got to come back down and get this. What does he do when he gets here? Goes through. What's he when he gets here? Goes through. He goes through these groupies because those factors are not squared. Now, where is the graph tangent to the x-axis? Right there. We did not refer to those as points of tangency. We call them bounce-off points, but that's what a tangent is. That's what a tangent is. What?
Wait, how do you know what both ends up again?
That's the end behavior of any even degree function. Starts up, ends up. Think of x squared. Starts up, ends up. Any even degree function takes that way. Okay, now we gotta go to number 14. I have some polynomial out there, and his roots are 1 and 2i. Okay, now kids, this is trouble, because you need to remember something important. If the roots are 1 and 2i, there's another root. Negative 2i, very good. Complex roots, that is, roots with i's, never come alone. They always come with their conjugate. So we actually have 3 roots. Now we don't need to know what polynomial that is. We need to write the equation so it looks like that. Okay? Now, you knew that 1 was a root because x minus 1 was a factor. So, if 1 is a root, what will be the factor? X minus 1. If 2i is a root, x minus 2i. X plus 2i. There we go. That's my polynomial. Chances are it's not going to look like that. It's probably going to be all multiplied out. So let's FOIL these two first. Always do the I ones first. That would be x squared minus 4i squared, because I have some cancellation going on in there, which you always will, by the way, with conjugates. That's why I'm starting with those two. What's this equal? X squared plus 4. And I got to multiply that by x minus 1, so another FOIL. X cubed minus x squared plus 4x minus 4. There's your polynomial. That should be the answer to the question. All right? Okay, now we're going to find both compositions. All right, so here we go. Remember that this means g of f of x. So we are going to find g of 2x squared plus 7x minus 1. It literally says g of f of x. Well, this is f of x. So I'm going to find g of that, which means I'm going to do what? I'm going to plug that in to my g function every time I see an x. So that will be 3 times 2x squared plus 7x minus 1 minus 2. 6x squared plus 21x minus 3 minus 2. 6x squared plus 21x minus 5. Now stop. We did something like that earlier, and I cautioned you. Does anything in the directions say solve? Nope. Is that thing set equal to 0?
No.
No. So you are done at this point. Okay? You are done at this point. All right, now we're going to do the same thing. This should be easy for you. It's exactly the same thing, only we're going in the other order. This says find f of g of x. So we're going to find f of 3x minus 2. Now what does that mean? We're going to plug 3x minus 2's in there into f. So that will be 2 times 3x minus 2 squared plus 7 times 3x minus 2 minus 1. So once again, we're going to FOIL here. If anyone in this room squares that and squares that instead of foiling, I will publicly humiliate you. And that goes for the groupies I don't even know. That is not good. You've got to FOIL this. So 9x squared minus 12x plus 4, 21x minus 14 minus 1. So 18x squared minus 24x plus 8. I don't know, I did that kind of fast. I hope my arithmetic worked out. Once again, this is the answer. Okay, don't FOIL, or don't solve it. No quadratic formula, no factoring, just stop. All right, what's next? I did that one so fast, I'm just going to double check real quick. Okay, all right, now I'm going to do number 16, which says, oh, I erased it, for g of x, find this. What does this mean? It's the inverse. Somebody said it. It's the inverse. Okay? Now, to find the inverse, do you remember what you do? You switch the y and the x's. Very good, Janet. You switch the y's and the x's. So x equals 3y minus 2. And then we just get y by itself. So y is going to be x plus 2 over 3. Now, I do want to caution you. Again, this is multiple choice. The answer may be written that way. It may also be written as 1/3 x plus 2/3. Is that the same thing? So you need to pay attention, because since you are matching somebody else's answer, you got to, you may have to do an extra step that you wouldn't normally do. Okay, number 17. Everybody should be able to do this. Number 17. We are rewriting an exponential form. What's the base here? 10. So 10 to the x equals 5. Done. 18 says do the opposite. Rewrite in logarithmic form. So you just work this backwards. So this would be log base e of x equals 7. But I promise you that isn't what it's going to say in the answer blank. Instead of log base e, what's it going to say? ln. That is what the answer is going to look like. Log base e, remember, is ln. 19 has a star by it. So we need our calculator. We also need to know a formula in order to do this problem. Your beady little eyes should zero in on the words compounded quarterly. O'Malley, you paying attention? It's not PERT, it's the other one, that's right. So P times 1 plus R over N to the NT. I know you're thinking, oh, I wonder if they'll give us the formulas. No. You're supposed to know that.
What about the other formulas that we got on the future last time?
Okay, now just wait a minute, Katie Klein. Mrs. Ford promised you something. What did I promise you?
Extra credit.
If it's not on the review sheet, it's not on the exam. So take a look at the review sheet, and I don't see that on there, so I think I'm good to go.
Everyone's fine.
I did not hear you say that.
I don't know.
Well, maybe I forgot to tell your class.
Yeah, I don't think it's in my
Or
class.
maybe you were asleep. All right, here we go.
She goes like this.
How much money would you have if you deposited $3,000 in an account paying 2.5% interest, compounded quarterly for 20 years? Now, 0.025, when you put in, and I don't, even if it's per, when you put in a percentage, when you have a percentage, you can't put it in as the percent. You got to put it in as the decimal. Do not make that mistake. Where did the 80 come from? 4 times a year for 20 years. Does this require logarithms? No. It only requires logarithms if your variable is an exponent. So here we go. I'm going to type this in. And again, if you don't get what I get, then we'll have to talk about it later. You should have gotten $4,938.47. Now, you will want to be very careful. Remember, this exam was written by 4 different teachers all working together. A couple of the teachers are big fans of saying things like, to the nearest dollar. Pay attention to that question. I mean, pay attention. Make sure you round off accurately, because we also all grade the same way, and they're going to take off if you round it accurately. So pay attention. Okay, the box. Here we go. The box problem. Yes. Okay. All right. So we have a box with no top. It's going to be made from a piece of paper that's 30 by 40. We're going to cut the corners out, fold up the flaps. You know, we made a zillion of these. You know what we're doing. Now, write an equation for the volume of the box. Now, these little corners are X. Too much talking. These little corners are X. When I fold up the flaps, okay, these are going to be like cut out. They're going to be gone. So these are like the flaps right here, right? So how wide is this right here? This is actually the bottom of the box now. How wide is that? It isn't 40 anymore. 40 minus 2x. So volume is 40 minus 2x. Times, now how wide is this piece? 30 minus 2x. Times x, because when you fold up the flaps of the box, this becomes the height, doesn't it? Now, let's just be serious about this for a minute. This piece of paper was 30 by 40. Your exam will not have a 30 by 40 piece of paper. It will have something like, 15 by 18. Okay? So what's different? Nothing. It's 15 minus 2x, 18 minus 2x times x, right? Yes. Structurally, there is nothing different. Now, that's the equation. Stop right there. Now we're going to sketch the equation. It is a calculator problem. We are going to use our calculator. But when we do this, and we have talked about this ad nauseum, when we do this, we got to stop and think about what are the actual possible values for x. X is this flap that I'm folding up. What is the smallest x can be? 0. It can't be less than 0, can it?
No.
So my x min is going to be 0. Now what about x max? What is the biggest x can be?
15.
15. You are right if you said 15. Tell the rest of them how you got 15. It's the half of the smallest dimension. Now before some of you get all confused and say, ooh, how do you know that? Just think about it for a minute. If you have 30 inches, is it possible to cut, let's say, 25 inches off here and 25 off here? No. The most you could cut off is 15, because that would make the whole 30. Now, What's Y min? Remember, this is your Y right here. This is your volume. What's Y min? 0. Volume can't be negative. What is Y max? We have no idea. So we're going to make up a number. I'm going to put in 1,000. Now, one of two things is going to happen. I am going to see what I want to see, which is this, or I'm going to see this. Now, what does this mean? My Y is not big enough. 1,000 wasn't big enough. So now I'm going to type in my equation. And by the way, when you type it in exactly the way you wrote it. Remember where your variable button is, use it. Oh my, 1,000 wasn't big enough, was it? So I'm going to go back to my window and I might make it 3,000. Still not big enough? Ooh, it's close though. 5,000 will work. I'm going to use 4,000. There's lots of numbers that'll work. I use 4,000, so now I got this picture on my screen. So, the question said, sketch the equation. Done. Caution. If you sketch more than that, because this curve does go on, if you sketch more than that hill, it will be marked wrong. Because in this problem, nothing other than the hill makes sense because x has to be between 0 and 15. So if you sketch more than that, if you don't set your window and you sketch this entire equation, whatever it looks like, I don't know, whatever it looks like, you will be counted wrong. You want only the part that makes sense in the problem. Okay, what is the maximum volume of the box? Well, second calc, maximum, left bound, right bound, and again, this should all be familiar. If it's not, we just are going to have to do some calculated remediation with you, but not on video. So it's this point is 5.657, comma, 3032.3025. Now, it says, what is the maximum volume of the box? The maximum volume of the box is this number right here. How do I know? Because when I wrote my equation, x was the corners and y was the volume. The unit on that would be, are these inches? The unit on that would be cubic inches. Volume is cubic inches. What size would the corners be to have a box with a volume of 2,000? Okay? Now, I want you to leave this picture on the screen. I want you to go back into y equals, and I want you to put in a second equation. Leave that one. I want you to put in y equals 2,000.
Where did you get 2,000 from?
The problem.
Never mind.
Now when I graph that, this stays in there and across comes this line. That's the line where the volume's 2,000, right? At this point and this point, the volume is 2,000. So now we go back into second calc. And this time, what do I choose? Not maximum, I already did it. Intersect. So I go down, I'm going to find this one. You would need to find them both. They're found the same way. I'm only going to take time to find one. So I'm going to press enter. I need to put this cursor over here somewhere. So I got it right here now, so I'll press enter. Now I need to set it over here somewhere. And the place where it equals 2,000, this point right here, is the point 2.19, 2,000. So the question said, what size would the corners be to have a box with a volume of 2,000? Well, one answer would be 2.19 inches. And then you would do the same thing and find this one, right? Now, when you do that, you come up with something, 10. This one is 10, 2000. Up here it is. Okay, I got that from my answer sheet.
She gets so excited.
Okay? Now, the next question says, what size would the corners be to have a box with a volume of at least 2,000? Now, you have already figured out that it's exactly 2,000 at 2.19 and at 10. So where is it at least 2,000? In between them. Because what can you tell me about the volume in between them? It's more than 2,000. And finally, what is the domain of this volume function? You've already answered that question. Where x min and max? 0 to 15. That's your domain. 0 to 15. Okay, we're going to do 21, then we're going to take a quick break because I got to stop the video. ln7 minus 2lnx plus lny. Write it as one logarithm. Before you can do that, gang, you have to take care of something. You got to take care of this. E becomes an exponent. So you have ln7 minus ln x squared plus ln y. Now you squish it all together into one logarithm, and what would it be? 7y over x squared. Why is it 7 times y? Because those are added. Minus means division. That's it. All right, let's take a quick break here. Real quick. We got a lot more to go.